Yusten here, and today I'm going to talk to you about scientific notation. So, in science, we have to deal with a lot of very large numbers. For example, the volume of an Olympic pool is 2,500,000 liters. Also, the diameter of the Earth is 12,700,000 meters. Now, those are some very large numbers with a lot of zeros after it. So, scientific notation is a way to condense these numbers down into something more manageable. So, the way it works by dealing with powers of 10. For example, 10 to the power of 1, 10. 10 to the power of 2, 100. 10 to the power of 3, 1,000. 10 to the power of, say, 6, 1 million. 10 to the power of 9, 1 billion. 9 zeros afterward. So this takes advantage of this by removing some of these zeros in these large numbers and replacing it with one of these powers of 10 instead. So the way it works is we take the decimal place, which is normally found at the end here, and we move it to make a number that is much, much smaller, in this case 2.5. Now our goal here is to make a number that's between 1 and 10, so a much smaller number, 2.5. That's a lot more easier to deal with. Now we still have to keep all of these zeros here, keep this value, so we take it and we times it by a power of 10, and it's the power of 10 that we remove. So you can figure that out, how many I removed, by just counting how many places I actually moved the decimal. So I moved it 1, 2, 3, 4, 5, 6 places. So I'm going to times it by 10 to the power of 6 because I basically removed a million. So this is 2,500,000 liters, or I could say it as 2.5 times 10 to the power of 6, or 2.5 million liters. Okay, go ahead and pause the video for a moment, and I'd like you to try this number right here, put it in scientific notation. Got an answer? Okay, so I'm going to take my decimal place, which is normally right here at the end, and move it right here to make the number 1.27. Okay, now how many spots did I move it over? I moved it 1, 2, 3, 4, 5, 6, 7 spots. So I'm going to times it by 10 to the power of 7 meters. Okay. Now, going backwards, a lot of times we have numbers that are already written in scientific notation. To go backwards here, this is referring to how many places it actually got moved. So this is 10 to the power of 22. That's a very large power here. Now, understand that the decimal point is right here. So this 5 actually does count as a place. It's not how many zeros we're adding. It's how many places we move that decimal point over. So I'm going to start rewriting this number out. I'm going to make lots of room here. So the 1, and then the 5 is the first one where I move the decimal place. So this decimal place goes that way once over the 5, and then it keeps going, but I have to add zeros for placeholders here. So that was one of them, and I go all the way up to 22. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. I like to add some commas in here just so I can see it. So 3, 3, 3, 3, 3, 3, 3 atoms. That's a lot of atoms. Okay? Now we can also do scientific notation not just with large numbers, but also with very small numbers. For example, the wavelength of a photon of blue light is 0.0000045 meters, or the mass of a human red blood cell, also really small, 0.0000000000027 kilograms. Very small numbers. Now, this also uses powers of 10, okay, but it uses negative powers of 10 to indicate smallness here rather than largeness. So 10 to the power of negative 1, 0.1, that's one decimal place. 10 to the power of negative 2, 0.01. 10 to the power of negative 3, 0.001, 3 spots. 10 to the power of negative 6, 0.0000001. 10 to the power of negative 9, 0.000000001, 9 spots over. Okay, so I'm going to remove some of the smallness of this by once again putting a decimal place and moving that decimal place to make a number between 1 and 10. So I'm going to go with 4.5. And then times 10 to the power of negative this time, because it's going to a smaller number. I'm going to count how many spots I moved it over. 1, 2, 3, 4, 5, 6, 7. Negative 7 meters. Okay, so this could be shortened to 4.5 times 10 to the negative 7. So pause the video again, and I want you to try this number right here, the mass of a human blood cell. Got an answer? I'm going to put my decimal point right here. Move this decimal point all the way from there over to there. So I'm starting with 2.7 times 10 to the power of negative. How many spots did I move over? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 spots over. Kilograms. Quick note, this 2 is a spot. I did move it past the 2, so it's not 14 zeros, it's 13 zeros and then the 2, because that 2 counts as one spot. Now, to go backwards in scientific notation, for example, this is the diameter of a hydrogen atom, 1.06 times 10 to the power of negative 10. That's a much small, very, very small number, but I want to turn this into regular notation again. So I am going to start off by writing this without my decimals. Okay, I'm moving the decimal place this way to actually get rid of it. So I've moved it once already. Now I'm going to start adding zeros. I'm going to go 10 spots. So that counts as 1. So this first 0 is 2 spots. 3, 4, 5, 6, 7, 8, 9, 10. And then there's my decimal place right there. Okay, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, then the 1, 0, 6. Okay, meters. So to summarize, to write numbers in scientific notation, you move the decimal point to make a number between 1 and 10. Count how many places you actually moved it, though. You rewrite the number, then you write times 10, and it's raised to the power of how many places you move that decimal point. If it's a positive power, we're talking about a number greater than 1, really, really large numbers. If it's a negative power, it's a number that's much smaller than 1, so it's going to be really small numbers. Now, adding or subtracting, we can actually do some math with scientific notation as well. When we're adding or subtracting, we have to make sure that these powers match. Now, they don't right now. I want to change the smaller one, which in this case is this guy here. So I'm going to keep this one exactly the same. So this one's still going to be 1.5 times 10 to the power of 3. But this one I want to change into times 10 to the power of 3. I'm still adding them together. Now to do that, I'm going to move this decimal point to the left. Always move it to the left if you're using the smaller one here. So use a smaller one, move it to the left. How many spots am I going to move it to the left? Well, that's the difference between these powers. 3 minus 2, 1. I'm going to move it one spot. So it's going to go over just one spot and become 0.81. Right? So 0.81 plus 1.5. All you got to do is add the numbers now that the powers match. So 0.81 plus 1.5 is 2.31. And then we take the power times 10 to the power of 3 and make it match. Now, this next one here we're doing subtraction. So I got to make these powers match. I want to do the smaller of these two. This one is actually the smaller one right here because negative 8 is smaller than negative 6. So I want both of them to be 10 to the negative 6. So this one we'll rewrite as 3.6 times 10 to the power of negative 6 minus, I'm going to leave that blank for a moment, 10 to the negative 6 for that one. So how many spots am I moving it over? Well, once again, the difference between these powers, 6 and 8, 2. So I'm moving it over 2 spots, and I always move it to the left. Okay, so 2 spots to the left, moves 1, and then I'm going to have to add a 0, so it's going to be 0.08. Okay, 0.08. So then I just do the subtraction as normal. 3.5 minus 0.08 is 3.42, and then it's times 10 to the power of negative 6. Now, real quick, significant figures when adding and subtracting. You go by decimal places, not by actually how many significant figures it is. So if I look at these rewrites here, this has 2 decimals, this has 2 decimals, so my answer should have 2 decimals. This has 1 decimal, this has 2 decimals, So my answer can only have the lowest of those, 1 decimal. So this actually has to be rounded, so it only has 1. So 3.4 times 10 to the negative 6 is my final answer. Okay, go ahead and pause the video. I would like you to try both of these problems right here. One addition, one subtraction. Got an answer? Okay, so this first one, I'm going to go with the smaller one right here. 10 to the power of negative 7. That's the one I'm going to change, so I'm going to stick with this. This one stays the same, 10 to the power of negative 5. Plus, leave that blank for a moment. This is going to be negative 5. Okay, so the difference between 5 and 7 is 2. So I'm going to move the decimal point to the left 2 spots. So that one's going to be 0.06, and then they just add together. So 4.16 times 10 to the negative 5. And this has 1 decimal, but this has 2. So I'm going to round it to only 1 decimal. So 4.2 times 10 to the negative 5 will be my final answer. Now this next one, this is the smaller one. So I'm going to round both of them to 10 to the power of 8. So this stays the same, 2.00 times 10 to the power of 8 minus, I'm going to leave that blank, times 10 to the power of 8. Move this decimal to the left again, always to the left. Move it 3 spots, because that's the difference between 8 and 5. So 3 spots over would be 0.009 times 10 to the power of 8. Okay. So now that we have our powers matching, we're just going to subtract 2.0 and 0.009, and I get 1.991 times 10 to the power of 8. Significant figures, though, I have to go by decimal places. This has 2, this has 3, so I got to round it so it only has 2. So I'm going to go with 1.99 times 10 to the power of 8 for my final answer. So to summarize this, to add or subtract numbers in scientific notation, you change the smaller power of 10 by moving the decimal point to the left, always to the left, if it's the smaller power, okay? By the difference in the number of powers, whatever those differences is. Rewrite the equation so both numbers have that same power of 10, and then you just add or subtract the numbers. And the answer has the same power of 10 as the ones in the rewrite. Rounding for significant figures, you go by decimal places in whatever the rewritten equation is. Okay? Now, multiplying or dividing is slightly different. It's actually easier. All right? Essentially, you can just ignore these powers for a moment. If we're multiplying or dividing, all we have to do is multiply the numbers like normal. We'll deal with the powers in a minute. So 5.0 times 4 is 20. Then we're going to deal with the powers. So we're going to take and times it by 10. And with these powers, this 2 and this 3, you just got to add them if you're multiplying. Add them together. So 2 plus 3 is 5. Okay? Now, this is not between 1 and 10. So I'm actually going to shift this decimal place over by 1 to make 2 times 10. And since I shifted it over, I'm going to add 1 to it, make it a 6. Now, significant figures, you go by how many significant figures you actually have in your things up here, these numbers. So this has 2, this has 1, so my answer can only have 1, which it does. So that one is fine for significant figures. Now, dividing, same thing. You do the division for these numbers like normal. 6 divided by 2 is 3. And then times 10 to the power of, this is a 20, this is a 5. Now instead of adding though, like you did with multiplication, you subtract for division. So 20 minus 5 is 15. Significant figures here, 1 and 1. So my answer can only have 1, which it does. So I don't have to do any rounding at all. Go ahead and pause the video. I would like you to try both of these problems, this multiplication and this division problem. Got an answer? Okay, so we are going to multiply 7 by 5.5, and I get 38.5, and then times 10 to the power of, I'm just going to add these powers. 8 and 6 make 14. Now, significant figures. This one only has 1, that one has 2, so I have to round, so my answer only has 1, which gives me 40 times 10 to the power of 14, which I'm going to move the decimal place over by 1, so it's between 1 and 10 again. So that gives me 4 times 10 to the power, and since I moved it over to 1, 15. Okay, final answer. Now the division problem. I'm going to divide 4.0 by 2.5, and I get 1.6 times 10 to the power of. Now I'm going to take negative 3 and minus negative 4. Just to be clear here, negative 3 minus negative 4 is 1. Okay, I'm subtracting because it's division, but that's actually a positive 1. So this is actually a power of 1 here. This has two significant figures, and this has two significant figures, so that actually already has two significant figures, which it should. So that's how you multiply or divide in scientific notation. To summarize this, you multiply or divide the numbers just as normal. Ignore those powers of 10. The answer, though, has a power of 10. So if multiplying, you add them, and if you're subtracting, if you're dividing, you subtract the powers. And don't forget to round for significant figures, whatever the lowest number of significant figures is in your equation. Thank you, and I hope you have a good day.